we go. Our second question on the distributive practice that deals with limiting and excess reagents. It reads, calcium hydroxide is neutralized with phosphoric acid. We're being asked to write the balanced equation. Calcium hydroxide is a base being neutralized with an acid. Calcium with its +2 charge, hydroxide with its -1 charge, CaOH taken twice is the formula for the base called calcium hydroxide. Acids and base neutralize. We will need the formula then for phosphoric acid. Ic comes from 8 as we're writing out our acid formula. Hydrogen who has a +1, the polyatomic ion phosphate carries a -3. We have H3PO4. Acid-base chemistry really is just nothing more than the old double replacement we're familiar with. Calcium goes to phosphate, hydrogen goes to hydroxide. So thinking about outers, inners, hooking by charge. Calcium, who carries a +2, phosphate, who carries a -3, we get Ca3PO4 taken twice. And when H goes to OH, we can write that as water or HOH to help us balance. Starting with the calciums on the right side, I notice there's 3. I'll begin with a 3 in front of the first reactant. 3 units of calcium hydroxide. I notice there's 2 units of phosphate on the right-hand side, telling me I need to double the acid. 2 units of H3PO4. Giving us 6 units of water. 2 times 3 are 6 H's, 3 times 2 are 6 OH's, 6 H's and 6 OH's make 6 waters. So we end up with a 3:2 to 1:6 stoichiometric ratio. We're being asked to calculate how many molecules of water form when 25 grams of calcium hydroxide react with 50 grams of our acid. We are given 25 grams of the first reactant, CaOH taken twice, and 50 grams of the acid, H3PO4. The target is molecules of water. We'll set up our 3 conversion parentheses, making the target molecules of H2O. We'll have 2 problems to do, comparing our answers to find the smaller of the 2. Same target, the molecules of H2O. When we begin, we've got to have a molar mass of calcium hydroxide for that first conversion. 40 for the calcium, plus 16 times 2 on the oxygen, and 2 more for the hydrogens. I'm finding a molar mass of 74 grams of CaOH taken twice, 1 mole on the top of our conversion. In the heart of our problem, I have 6 moles of water, our want, set over the given, its coefficient of a 3. We have 6/3 as the stoichiometric ratio. We want to know the number of molecules. We will use Avogadro's number, 6.02 times 10 to the 23 molecules of water over 1 mole of water. Divide, ratio, multiply, the 3 steps to stoichiometry. I'll hit for us 25. Divide by 74 times 6/3 times 6.02 E23. And I find 4.1 times 10 to the 23rd molecules of water. In the second problem, it's the same target. We still want to know the molecules of water, but now we're starting with the second reactant, the phosphoric acid. We'll add its molar mass to place in the first conversion, 3 from the hydrogen, plus 31 from the phosphorus, plus 16 times 4 gives us 98 grams for the molar mass of H3PO4. The want over given ratio shows 6 moles of our water for every 2 moles of the H3PO4, a 6/2 stoichiometric ratio. We'll still use Avogadro in our last conversion, 6.02 times 10 to the 23rd molecules of water in every 1 mole of water. 50 over 98 times 6 over 2 times 6.02 E23 gives me a value of 9.2 times 10 to the 23rd molecules of water. The magnitude of the times 10 are both the same. They're both to the 23rd power. So I simply compare the 4.1 to the 9.2, circling the smaller of those two and indicating that as my maximum yield. The calcium hydroxide was labeled as our limiting reagent, giving us excess amounts of acid. Notice in this particular review problem, we're not being asked to calculate how much excess is left over. It's just two straight calculations. Circle the smaller of the two.